Welcome back to what will be our second and final video lesson on organic chemistry. Thanks for joining us. We started last class, or I guess our last video, we were talking about different types of organic compounds. And we're going to be continuing today looking at the specific one of alkanes. So alkanes are our simplest molecules in organic chemistry, and they consist only of carbons and hydrogen. Those are the only two elements that show up in alkanes. And we also have only single bonds happening between our carbons and hydrogens. So that means if I know that there's going to be a certain number of carbons and hydrogens stuck together, I can always predict how many of each there's going to be relative to each other. So for every carbon I have, I know that I'm going to be having two hydrogens sticking off of it, but I might stick on another carbon and then another one and another one. So it's kind of that problem from math once upon a time you may have encountered where you have tables that you're setting up. Two people can sit at each table. How many tables do you need and how many people can sit for your dinner party? You got two people sitting at each table, but then you can put one on each end. And so that's what's happening with our alkanes, that once you have all your carbons there, you're going to throw your two H's on the end. So that's that two for each carbon, and then the two sitting on the end. We can take a look, put this together. If I have 4 carbons, well, that means my N value is 4. And I can use this piece of my alkane general molecular formula and say, well, I'm going to have this many hydrogens. Instead of N, I'm going to put in 4 plus 2. That gives me 8 plus 2 is 10. So I know that if I have 4 carbons, I'm going to have 10 hydrogens attached. I can also work backwards. If I know my compound has a certain number of hydrogens, I can then work backwards using this relationship to get my carbons. Now, how does our molecule look like, our C4H10? Well, as you have drawn out on your handout, we could put all of those carbons in a row and then attach the hydrogens so that each carbon still has 4 bonds. Remember that that's the case. Carbon always forms 4 bonds, and in alkanes, they're all single bonds. And either stuck to it's an adjacent carbon or to a hydrogen. So there's that simple one. We could also play around with it a little bit, start connecting them differently. Instead of putting that 4th carbon on the end, I'm going to make it branch off here. Okay, so this one, this carbon here in the middle, 1, 2, 3, 4 bonds coming off of it, 3 to other carbons, and 1 to a hydrogen to fill up that 4th bond that has to be there. So both of these molecules have the same molecular formula of C4H10, but they're going to react differently. They're different chemicals. Because of the different structures, you can even imagine how something like a longer, skinny molecule might behave differently than what seems to be a bit more of a clumped up, weird, twisty molecule. So these two different molecules are called isomers of each other. Iso means the same as a prefix. So it's the same parts. If you've heard of a polymer, mer kind of means the building blocks. So the building blocks here are the same. I still have 4 carbons and 10 hydrogens, but I've built them differently. So it's the same number of Lego bricks that I'm using. I'm just configuring them differently, and that's what's giving me my isomers. Looking at these diagrams, one always has to ask, well, is there a shorter way to draw this? Do I have to do all of these details? And of course, the answer is yes. There's another way that we can do it. And the way we do that is called a condensed structural formula. So what we do is we look for each particular carbon and we see what's attached to it. So I have this carbon here, and yes, it's attached to the next one, but I kind of have like this group going on here. So then I go to my next carbon, and I've got this group here, and then I got another group, and then another cluster here. So for my condensed structural formula, I go ahead and list every single one of these clusters. So I started with a CH3, and then I have a CH2, C with two H's attached. Then I have this C, which has two H's attached. And then I have this C, which has three H's attached. Okay, there's no shortcutting this. We have to list every single carbon and then how many hydrogens are attached to it. We can't try to condense this further because if I do try to put brackets or say, well, I have two of them, that's actually a different type of notation, and we're going to encounter that now with this isomer. So same process. I'm going to look at, for my longest chain, I've got 3 carbons in a row here. So here's my first one. So there's CH3. And then here's a second one. There's my CH. And the second one has this branch coming off of it. So it doesn't have just this straight long chain. If I look at the second one here, I've got this branch that comes off. So that branch gets listed next, and we put it in brackets. Those brackets indicate that this CH3 isn't part of the long string of carbons. It's branching off of this carbon here. Okay, so that's why I couldn't just say I've got 2 CH2s in brackets somehow there. Here I've got my straight chain part, so I've got the CH3, the CH, and then my last one here, my CH3. So I've got this long chain of this one, and this one, and this one is my branch. And so that's the notation that we use. For the rest of this video, we're only going to be looking at the straight chain carbons, or hydrocarbons, and that makes it a little bit easier for these condensed structural formulas. We'll go over the branched versions and how to draw them in a bit more detail once we're back in class. Let's take a look at our first alkane molecule here. So this is decane. Gets its name because it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons in there. So dec is the prefix for 10. And you've got a list of those coming up once we get into the names. If I wanted to do the skeleton diagram, just so that you kind of know what's happening there, we'd have 1, 2, 3, 4, 5, 7, 8, 9, 10. So remember there's a carbon at the end of each one of these sticks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons, and it's not showing anything else. So the rest of the bonds that each carbon has to make, remember carbon has to make 4 bonds, not an option, there must be 4. So here I have a carbon and it's attached to this carbon. So I'm showing that part there. And what's not shown are all those hydrogen bonds. Okay, so my skeleton drawing is just showing, actually I should fix that up, make that a little clearer. Skeleton drawing is just looking at these parts here. Those are the bonds. Again, I'm not going to make you draw the skeletal diagrams, but I do want you to kind of know what's going on with them and understand where they come from. Okay, so those are the bonds that are shown in our skeletal diagram, which should also not be quite so zigzaggy. You should have, usually they have nice, more even lines and showing the angles more accurately. All right, let's get back to the easy stuff. Our molecular formula here, well, I've got 10 carbons, and either I can count them or I can take advantage of the fact that each table seats 2, and I'm going to add 2 at the end, so it's going to mean that I have H22 here. Okay. Now, what you do need to know how to do is our condensed structural formula. So what we do is we figure out our longest chain, which is obviously all of them, and we just start grouping them together. So here's one carbon group, and here's our next cluster, and our next one, and so on. And so we have to list all of them. Okay, so it takes us a while, but there's our first CH3, and the next one is a carbon with 2 H's, so it's a CH2. And we go on and list all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then our last one's going to be a CH3. Doesn't seem very condensed, but compared to the original diagram, it's an improvement. It's tempting, but we're not allowed to go and just say, well, I've got CH3, and then I've got a whole pile of CH2s. I've got 8 of them, and then another CH3. We can't do that because this notation indicates that what I have is a CH3 with 8 CH2s hanging off of it somehow, which is physically impossible when this carbon can only make 4 bonds to begin with. Okay, so the condensed structural formulas, we still have to list off what's going on with them. They make a bit more sense in terms of where that condensation is coming from, because right now this looks just as long as the diagram itself. Once we start looking at the more complicated compounds, especially with the branched ones, you'll see like, oh, okay, that's the shortcut and why it's actually helping us with these things. So we've got our general molecular formula for our alkanes. So let's move on to naming them. And naming them is really straightforward. You start with the prefix based on the number of carbons, and then you just add ane at the end. Okay, so if I have 4 carbons, it would be butane. If I had 13, it'd be tridecane. Notice that these prefixes are a little bit different than what you may have seen before. Take a look at 3. It's not tri, it's prop. Okay, we've got penta and hex and hept. Those ones are kind of more normal, but for 1, 2, 3, and 4, they're not what you are used to. Be careful of that and don't make assumptions about what the prefix is supposed to be. Also, put these on your periodic table so that you have them for your final exam. We will not be providing this table for you, so make sure you have it somewhere in your notes for when you write your final exam. So let's try some of these examples. Here's our first one. Let's try naming this molecule. So I've got C3H8. We don't care about the H8 for the naming purposes. I'm just going to take a look and say, well, I've got 3 carbons, and if I look over 3 here, 3 is prop. So the name of this is pro. And it's an alkane, so ane, propane. Okay, and now let's draw it out. So I know that I have 3 carbons. 1, 2, 3. And we can draw it out the long way where I'm going to put an H on all of these. But I don't want to do that because that takes up a lot of space. So instead, I'm not going to have those branches coming off. Maybe I will, just so you can see what I'm getting at. Okay, so this is the long way that we don't want to do. Right, we'll draw all of those H's. Super annoying. You don't have to, but I'll show you where I'm going with all of this. Okay, so with that, a better way of drawing it would be just to have, well, let's say this first one's, I've got CH3, attach that to a CH2, and attach that to another CH3. Okay, this is, I don't know what it's called to this type of diagram, but it's kind of our basic molecular diagrams. This is an okay way of drawing this molecule without all of those H's. Okay, so here's our drawing of our propane molecule. The condensed structural form is not very different because of the fact that this is a really simple molecule. But here's our condensed structural form diagram. I can't remember what it's called. Yes, the condensed structural form. Okay, so I'll make a note of that. Notice that the main difference is lacking those dashes in between. And like I said, it's because we don't have really anything interesting going on with this molecule. This is our condensed structural form. of propane. Take a look at the next example. So I've got C5, don't care about the 12. So I'm going to take a look. There's that number. So I go to the 5. So I take the pent, make that my prefix, and I'm told that it's an alkane. So all we do is add ane onto the end. Don't overthink things. Okay. Now if I wanted to draw it, I'm going to have a carbon attached to another carbon, attached to another one, 4, 5. So each of these in the middle can have 2 hydrogens coming off of them. And this one can have 1, 2, 3. So CH3, and same thing over here, CH3. You don't have to like draw the lines what's connecting, anything fancy. We just try to show with a longer dash that there's a bond happening there. Our condensed structural formula is the same thing as this molecular diagram, just without the dashes. Not terribly exciting at this. So there's our condensed structural formula, and in green is the molecular formula. So if you're asked for a condensed structural formula, you're looking for this, and if a question asks you to draw a molecule, you're going to do this here. Take a look at the next example, pause the video and see if you can come up with the name, and then the diagram and the condensed structural formula. I've highlighted all of the pieces that help us put our name together. And we know that this one is called nonane. Here's our diagram of the molecule. So here's all that you really need to have when you submit an assignment or anything. It's generally accepted in the field of chemistry that that's your molecule. But here's the diagram of all of the bonds just to show you where that came from. You may have caught on by now, there's a bit of a pattern. With alkanes, your end of the branch is always CH3, and everything in the middle is a CH2. All that's left now is your condensed structural form. And there's our condensed structural formula. It's the same thing as the diagram, just without the dashes. Like I said, that's only true because we're dealing with these long chain alkanes. We haven't started branching them off. And we'll go over that on the 14th of December when I see you guys next. All right, take care until then. We'll see ya.